Hello, in this lecture I will prove the Pythagoras theorem. The Pythagoras theorem relates to a right triangle. A right triangle is a triangle with one of its angles equals to 90 degrees, like this triangle. This angle is 90 degrees, and it says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Or in mathematical notation it says that c square equals to a square plus b square. In order to prove the equation, I actually built a copy of this right triangle here, and I built the side B on a line of side A. It is a straight line, and actually I built a perpendicular side A to side B. So in the right triangle, the angle between side A to side B is 90 degrees. Okay, so we have here two triangles that coincides to each other, because side A in the right triangle equals to side A in the left triangle, and side B in the right triangle equals to side B in the left triangle, and also the angle between side A and side B in the right triangle equals to the angle between side A and side B in the left triangle, and both of those angles equals to 90 degrees. So according to the rule of angle side, these two triangles coincides to each other. That is to say, if you have in two triangles two sides that equal to each other, and also you have the angle between those two sides that equal to each other in the two triangles, then those two triangles coincides to each other. Okay, so because of this, the right triangle coincides to the left triangle, and from that we can deduce that if in the right triangle this side is side C, then in the left triangle this side must be also C, because of the rule of the corresponding sides in coincides triangles. And suppose that the side with the angle between side B to side C is alpha, then the angle between side B to side C in the left triangle must be also alpha, and we can say that the angle between side A and side C is x, because we don't know the size of this angle, so we label it as x, as unknown. But we do know that in every triangle in the world, the sum of its angles is always 180 degrees, and for that reason alpha plus 90 degrees plus x equals to 180 degrees. Okay, so we can write that alpha plus 90 degrees plus x equals to 180 degrees. No matter in which triangle you are talking about, in every triangle that you could imagine, the sum of its three angles must be 180 degrees. So we can write this equation that alpha plus 90 degrees plus x equals to 180 degrees. And if we subtract 90 degrees from both sides of the equation, then we will receive that alpha plus x equals to 90 degrees. As you can see here, alpha plus x equals to 90 degrees. And if we subtract alpha from both sides of the equation, then we will get that x is equal to 90 degrees minus alpha. Okay, so we subtracted alpha from both sides of the equation. We get that x equals to 90 degrees minus alpha. And in the middle triangle, we don't know which angle is this angle between side C in the right angle and side C in the left angle. So we will label this angle as y. It is unknown angle. But we do know that in every straight line, if we look on if it relates, for example, to this straight line AB, and we look on the bottom side, the sum of the angles on the upper side must be 180 degrees. X plus y plus alpha must be 180 degrees, and so is the angles in the bottom side of the line must be 180 degrees. In total, the sum of the angles in a straight line is 360 degrees. So if you look only on in the upper side, the sum of the angles in the upper side of a straight line is 180 degrees. So we can write another equation that x plus y plus alpha equals to 180 degrees. As you can see here, if we look only in one side of a straight line, the sum of its angles must be 180 degrees, so x plus y plus alpha equals to 180 degrees. But we know already that x equals to 90 minus alpha, so we can substitute x by 90 minus alpha. Okay, here we substituted x by 90 minus alpha plus y plus alpha equals to 180 degrees. Here we have minus alpha and plus alpha, minus alpha and plus alpha equals to 0, so we can eliminate alpha from the equation, and we can simply write that 90 plus y equals to 180 degrees, 90 degrees plus y equals to 180 degrees. Alpha was eliminated from the equation, and if we subtract 90 degrees from both sides of the equation, then we will get that y equals to 90 degrees. We got that y equals to 90 degrees. Okay, here y equals to 90 degrees, so we can write here that y equals to 90 degrees, so we can say that the middle triangle is a right triangle. So actually, we can also say generally that all the three triangles here are right triangles, because from the beginning this right triangle was a right triangle, because the Pythagorean theorem relates only to right triangles. So from the beginning we had a right triangle, and in this, the middle triangle, we found that it is also right triangle, and if we relate to the left triangle, then we actually raised perpendicular in size A to side B. So we built a right triangle. Okay, so all of the three triangles are right triangles, and now we will calculate the area of this trapeze. Trapeze is a square with parallel sides. It has one parallel sides. In this case, A parallel to B, so it is a square with parallel sides. We will calculate the area of this this trapeze in two ways. Then we will compare the results of the first calculation to the second calculation. Of course, they must be equal, and we will build a equation that expression 1 equals to expression 2, and from this we can derive the Pythagorean theorem. So we will start to calculate the area of this trapeze. In the first way, we will label the area of the trapeze as S. The area of this trapeze will be called S. S equals to the sum of the sides that are parallel to each other. A is parallel to B, so it is A plus B, times the height of this trapeze that is also A plus B, and we divide this by 2. So the first way to calculate the area of this trapeze is actually it is the sum of the parallel sides, that is A plus B. A is parallel to B, times the height that is also A plus B. A plus B times A plus B, and we divide all by 2. Then the second way to, this is the first expression. The second expression, we will calculate the area of this trapeze in another way, and we can actually say that the area of this trapeze equals to the area of its components. This trapeze composed of 3 triangles: the right triangles, the middle triangles, and the left triangles. So the areas of the sum of the areas of these 3 triangles will be equal to the area of this trapeze. So we will calculate the area of the first triangle. The area of a triangle is its base times its height to the base divided by 2. The base of the right triangle is A, and the height to the base is B, and we divide all by 2. So it is the area of the right triangle is A times B divided by 2. And the area of the middle triangle is the base of the triangle times the height to the base divided by 2. So the base of the middle triangle is C times the height of the base, the height to the base, that is also C, divided by 2. So in total the area of the middle triangle is C times C divided by 2. And the area of the left triangle is the base of the triangle times the height to the base. The height of the triangle to the base, so it is B is the base times the height to the base is A divided by 2. So it is B times A divided by 2. So in total the area of this trapeze is the sums of the areas of the 3 triangles. The area of this triangle plus the area of this triangle and the area of this triangle. So in total we can say that the area of the trapeze, when we calculated it in the second way, is the sum of the area of the 3 triangles. The area of the right triangle is A times B divided by 2 plus the area of the middle triangle, that is C times C divided by 2 plus the area of the left triangle, that is B times A divided by 2. And as I have already told you, the area of the trapeze in the first calculation must be the same of the second calculation, so we can say that expression A equals to expression B. The first expression equals to the second expression. Yes, it is the same trapeze that we calculated the area in two different ways. So the first expression equals to the second expression, so we can write that equation. The first expression is A plus B times A plus B divided by 2, and it equals to the second expression, that is A times B divided by 2 plus C times C divided by 2 plus B times A divided by 2. So the first expression equals to the second expression because both of the expressions is the area of the trapeze. So we can multiply this of both sides of the equation by 2. We'll get that A plus B times A plus B equals to AB plus C times C plus B times A. So after we multiplied the equation by 2, we got that A times B times A times B equals to AB plus C times C plus BA. C times C is C squared, and A times B plus B times A is 2AB. So we can write it again. Okay, as I have already told you, A times B plus B times A equals to 2AB, and C times C is C squared. Now we will open the brackets in the left side of the equation. So A times A is A squared, A times B is AB, B times A is BA, and B times B is B squared, all is equals to 2AB plus C squared. Again, A times B plus B times A is 2AB, so we'll write it. So we have A times C, A squared plus 2AB plus B squared equals to 2AB plus C squared. Now we can subtract 2AB from both sides of the equation. So after we subtracted 2ab from both sides of the equation, we got that a squared plus b squared equals to c squared, and that is actually the proof that the square of the hypotenuse, hypotenuse in a right triangle equals to the sum of the squares of the perpendiculars, or c squared equals to a squared plus b squared. So we can summarize the proof and say that we had a right triangle, and we needed to prove that c squared equals to a squared or plus b squared, or that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. C squared equals to a squared plus b squared. In order to prove this equation, we actually built a copy of the right triangle here. The copy of it is this small triangle, and we found the angles x and y, and then we calculated the area of the trapeze. The trapeze is the square with pair sides that equal to each other. Here A is two sides that are a pair of sides that are parallel to each other. Here A is parallel to B, and we calculated the area of this trapeze in two ways, and then we said that the first expression equals to the second expression, because it is the area of the same trapeze. And then we actually derived the Pythagorean theorem by developing the equation, the first equation that equals to the second equation. We multiplied it by 2, and we opened the brackets, and at the end we got the Pythagorean theorem that says that the square of the hypothesis, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, or c squared equals to a squared plus b squared. Okay, thank you very much.